Right, so let's say the sound might not work on this. Has anyone actually solved the contained subset issue, first of all? It's not that difficult, really. For each set item in subset dot values, if item does not equal hold on. He says it's quite easy, then somebody realises he's doing it completely wrong. Right, we need to go through every item and see if there's a matching item in the subset. If values dot contains key item name equals true. If item does not equal set item Okay, so what happens is it's going to go through the entire subset. If at any point it finds an item in the subset that doesn't have the same item name in the main item, it's going to return false, because obviously if something in the subset has a different name to something in the, if the item's name does not appear in the superset, that means it can't exist. It then double checks to see if the item is actually identical to the set item that's in the set. If the item is not identical, it returns false as well. So even if it has the same name but is actually a different object, it returns false. If it gets through the entire subset without any issues, it returns true. So how do we test that? Well, let's do a test case, a test method. Public void subset testing. It's going to be very similar to having two sets originally. I'm then going to create a series of set items, 1, 2, 3, 4, 5, 6, 7, 8. Let's do. Obviously, it's going to complain at the fact that there's. I'm just going to call this item 1. Doesn't matter what the value is each time because they're just going to be made up for item 5, item 6, item 7. So I'm going to have 8 items. Obviously I need to push all those into each of the values. So what I'm going to do is the first items 2, 3 and 4, 1, 2, 3 and 4 are going to be into A and B. 5, 6, 7, 8 are only going to be in A. 5, 6, 7, 8 are in A. A dot subset contains subset B should equal true. So assert are equal true. A should contain subset B. It should also be tested that B does not contain subset A. The next thing I'm going to test is I'm then going to add another item that's going to have the same name, item 5, and pushed to B, because item 5 was not pushed to B originally. Now this will be a different item even though it's got the same name. And then I now need to make sure that this should be false, showing that even though an identical item has been added, it's a different copy of an item. It's like a clone. I'm then going to pop item 5 out of B, check that this now becomes true, so item 5 is removed. Finally, I'm going to, oh, I can't do that because I was doing value. I was going to do something else. Hold on, let's do, if I pop out of A item 1, this should also equal false now, because something that is in B is no longer in A, and therefore that should equal false. I know it's quite a lot of code, so I'll let you just run it, but I'll just test it to check that works. This should actually pass first time if I've got my code right. And it's failed. I'm able to... Right, where's it falling over? Oh, you can't use a for each loop, that's why, in a... oh, sorry, I know what I need to do then. I need to make a slight change to contain subset. Subset values. Oh, hold on, no. Is that right? Yeah. Dot. Oh, I can do it. Sorry, it's me. I've just using the wrong thing. That should now work. I can do it for each if it's loops. Yeah, that's fine. It does work. Sorry, you'll need to change that line of code that's on the for each statement I've highlighted in blue. It's subset.values.values. It's the values within the hash table that's within the set. But my test works, so that proves that this subset system works, or should do. Now, while you're just doing that, I'm going to start adding some new code here. What's it called? Intersection. Let's get this right. So So the next two areas of code is the intersection and exclusion, where we're looking at returning a new set which just contains the items that are in both the set we're looking at and the second set we put in, and exclusion, which returns all the items in the first set that are not in set 2. Okay. And your final task for today is to do tests for both the intersection and exclusion as well. In fact, let's do a third one just to make you actually do some work. I know, it's ridiculous, isn't it? I'll add it. I know you're still doing the exclusion, intersection, exclusion. So what I'll do is I'll just pause the screen for a moment if you're copying, and just put it on here, and then you can see it in a second. I'll try and shorten these so you can get them on. Unfortunately, they're quite wordy, so getting them all to appear on the screen in one go is going to be quite small. Right. Okay, so I know it's only shrunk down in size, but there you go. You've got intersection, exclusion, and include. What include does is if you give it another set of data, it adds it into this current set, and you've got the choice with Boolean overwrite name match that if it finds an item in the current set with the same name as the other smaller set, you can choose either to overwrite it or ignore it. And that's what the code does there. All that code should work correctly if I've got my code right. It looks right to me, but I might have made a mistake somewhere. But that's up to you now to test those items. In the same way, you can actually write your own code called exclude, which is where it takes out anything from the current set if it's in the subset. And that's everything I'd like you to finish off with today.